We've just heard the news that Perseverance is alive on the surface of Mars.
These images from NASA's many cameras on board track every tense moment of the perilous landing last Thursday.
Mars, a planet that once held flowing rivers and vast lakes, now stands as a desolate world, its secrets buried beneath layers of ancient rock. NASA's Perseverance rover has delivered the most remarkable footage yet. 4K visuals that reveal evidence of things we've never seen before. In this video, we're going to bring you face to face with the truth that's been there the entire time, just hidden from view. The rovers, our eyes on Mars. On August 6, 2012, NASA's Curiosity rover descended onto the dusty Martian surface in Gale Crater. This groundbreaking landing used the ambitious Sky Crane system, an innovative design that gently lowered the rover to the ground using cables after decelerating its fall with retro rockets. This method allowed for a precise landing in Gale Crater, a 154-kilometer-wide basin rich in geological diversity. The site was specifically chosen because of the central Mount Sharp, a layered mountain potentially holding billions of years of Martian history in its sedimentary rock layers. Curiosity's primary mission was to answer one fundamental question: had Mars ever harbored environments that could support life? To accomplish this, the rover was fitted with a sophisticated suite of instruments, each serving a unique purpose. The ChemCam uses laser technology to vaporize small portions of rock and analyze their chemical composition from a distance of up to 7 meters. The Mastcam, with its 2 camera systems, delivers detailed high-resolution images and stunning color panoramas, aiding in the selection of prime sites for further study. Another critical tool, the Sample Analysis at Mars Suite, made up of 3 instruments working together to analyze gases, isotopes, and organic compounds in rock and atmospheric samples. Curiosity has made massive discoveries during its mission. It confirmed that Gale Crater once housed a lake system, supported by layers of mudstone containing clay minerals. These clays form in the presence of water, suggesting the crater had standing water for millions of years. The rover also detected fluctuations in methane levels in Mars's atmosphere, which, intriguingly, could have biological or geological origins. The presence of organic molecules found within rock samples hinted that Mars's ancient environment might have been conducive to life. These findings laid the groundwork for exploring deeper questions about Mars's habitability, but there was more to come. Perseverance, the scientist and sampler. Building on Curiosity's trailblazing success, the Perseverance rover embarked on a more daring mission, landing in Jezero crater on February 18, 2021. Unlike Gale Crater, Jezero spans 49 kilometers and harbors a unique combination of features: an ancient river delta and a long-dried lakebed, rich in carbonates and clays. These materials are considered ideal for preserving biosignatures, making the site a prime candidate in the search for evidence of past microbial life on Mars. Perseverance's mission extends beyond mere exploration. Its objectives include the search for ancient life, the collection of Martian rock and soil samples for a future Earth return mission, and the testing of cutting-edge technologies to advance human exploration. Equipped with a sophisticated suite of instruments, Perseverance excels at conducting detailed investigations. Sherlock, mounted on its robotic arm, identifies organic molecules and minerals that may signify habitable environments, while PXL produces high-resolution chemical maps of Martian rocks. Meanwhile, the Mastcam Z camera system enables researchers to closely analyze distant targets with precise zoom capabilities. A groundbreaking addition to Perseverance's toolkit is the Ingenuity helicopter, the first device to achieve powered flight on another planet. On April 19, 2021, Ingenuity completed its inaugural flight, paving the way for aerial exploration. It continues to play a critical role in supporting Perseverance, scouting potential sites of interest and aiding navigation. Another game-changing innovation on board is MOXIE, which has successfully generated oxygen from Mars's carbon dioxide-dominant atmosphere, a vital step for future manned missions. Since its arrival, Perseverance has already achieved remarkable feats. It has collected multiple rock core samples, particularly from sediment-rich sites in the Delta region, likely deposited by flowing water billions of years ago. These samples could hold critical clues to Mars's ancient habitability and the potential for past life. These samples are carefully sealed, ready for a potential retrieval mission that will bring them back to Earth for detailed analysis. Innovation in exploration. Both Curiosity and Perseverance exemplify NASA's leap in autonomous navigation and mobility, allowing these rovers to traverse the unforgiving Martian surface with minimal guidance. Perseverance features the AutoNav system, a vast improvement over Curiosity's navigation. AutoNav processes terrain data in real time, enabling the rover to identify hazards and choose safer paths. This efficiency has dramatically increased the distances Perseverance can travel during its operations. Perseverance's ability to capture and transmit footage in 4K resolution also represents a technological leap. The visuals reveal Martian landscapes with an unparalleled level of detail, allowing scientists and the public alike to observe sand ripples, rock textures, and even the thin haze of the planet's dusty atmosphere. These images aren't just for show, they provide critical data to help geologists and astrobiologists pinpoint specific features worthy of deeper investigation. Curiosity paved the way for much of this success, offering vital lessons on everything from system durability to optimizing science objectives. For example, Curiosity's extended mission revealed that it could endure Martian winters and significant dust storms, which informed the design of Perseverance's reinforced hardware and energy systems. Together, Curiosity and Perseverance are achieving what was once only dreamed of, turning the distant red planet from an enigma into a site of groundbreaking discoveries.
Perseverance will now retreat to Van Zyl Overlook.
Through meticulous engineering, innovative technologies, and their sheer resilience, these rovers are rewriting what we know about Mars. They have bridged the gap between hypothesis and evidence, advancing our understanding of a planet that might once have mirrored early Earth. NASA's Mars rover Perseverance has been sending back breathtaking footage, revealing Mars in unprecedented detail. Among its most notable achievements is the documentation of its descent and landing in Jezero crater on February 18, 2021. This event was captured through multiple cameras, providing an unparalleled look at the intricate landing process. In a groundbreaking first, NASA also released 4K resolution visuals of Mars, combining high-resolution images taken by the Curiosity, Spirit, and Opportunity rovers. Despite bandwidth constraints limiting direct HD video transmission from Mars, these visuals were meticulously stitched together from photos to provide a clear and stunning representation of the Martian surface. Perseverance's exploration of Jezero crater has uncovered ancient river delta formations, offering significant insights into Mars' history. Its advanced imaging technology has allowed researchers to create detailed panoramas, shedding light on potential signs of past life. The Curiosity rover, though older, continues to contribute valuable data with its analysis of Gale crater's geology, complementing Perseverance's efforts. Together, these rovers enhance our understanding of Mars, creating a comprehensive picture of its past environments. These machines, working millions of kilometers away, bring us closer not only to the answers locked in Mars's geology, but also to the larger goal of exploring Mars as a future frontier for humankind. Revealing Mars: landscape, climate, and geological history. Mars's surface offers a rich tapestry of geological features, each with clues to the planet's dynamic past. Gale Crater, Curiosity's exploration site, showcases an intriguing array of sedimentary rock layers within its central structure, Mount Sharp. These strata represent billions of years of Martian history, with each layer preserving details about the environmental conditions at the time of its formation. Scientists have identified signs of water-altered minerals, particularly clays and sulfates, which point to prolonged interactions with liquid water. Mount Sharp's towering slopes act like a time machine, providing an invaluable record of Mars' ancient wet periods transitioning into aridity. In comparison, Perseverance's exploration of Jezero crater centers around a river delta that once emptied into a long-gone lake. The delta's fan-shaped deposits of sediment are relics of flowing water that carried and deposited material over eons. These sediments include carbonates, materials known to preserve microscopic fossils on Earth. Detailed images from Perseverance reveal winding riverbeds and layered deposits, tangible signs that water not only existed, but was stable for extended periods. Beyond these craters, Mars displays sweeping sand dunes, towering impact craters, and distinctive rock formations like the famed blueberries discovered by the Opportunity rover, tiny spherules formed by mineral-rich water. Wind erosion continues to sculpt the planet's landscape, creating rippling patterns of fine dust that evoke a dynamic system still active beneath Mars's quiet appearance. Mars has undergone dramatic climatic changes over its 4.5 billion-year history. Early in its existence, Mars had a thicker atmosphere and supported large quantities of liquid water, as evidenced by sedimentary rock layers within craters and valley networks. Analysis of these layers by both rovers shows how minerals like clay formed in wet environments, further confirming the role water played in shaping the Martian landscape. Curiosity's findings in Gale Crater indicate that lakes existed for millions of years, providing habitable conditions. Similarly, Perseverance's studies in Jezero Crater highlight the delta and lake bed's potential to preserve organic molecules, crucial for understanding Mars' wetter epochs. However, Mars gradually transitioned into a cold, dry planet. This shift, largely driven by the loss of its magnetic field, allowed solar wind to strip away most of its atmosphere. This collapse exposed the planet's surface to harsh cosmic radiation and froze its remaining water into underground reservoirs or polar ice caps. Today, surface water exists only as briny trickles or sublimating frost, remnants of a once thriving hydrological system. Mars's current atmosphere is 95% carbon dioxide, with a surface pressure less than 1% of Earth's, making it incapable of sustaining liquid water. Still, the planet's thin air holds valuable insights into its history. Isotope studies by Curiosity's SAM instrument reveal the preferential escape of lighter gases over billions of years, helping reconstruct the timeline of atmospheric loss. Seasonal variations in methane levels, detected by Curiosity and orbiting spacecraft, remain one of the most intriguing atmospheric phenomena. While methane can result from geological processes, its sporadic and localized spikes raise questions about possible biological activity beneath the surface. Perseverance, with its advanced sensors, aims to follow up on these findings, offering additional clarity. Dust storms, another defining characteristic of Martian weather, can envelop the entire planet, reducing sunlight and temperatures. Perseverance and Curiosity's weather instruments have provided real-time data on these events, improving predictions for future missions. Observing these storms also reveals how wind shapes Mars's surface today, reminding us that, despite its ancient appearance, the planet remains geologically and atmospherically dynamic. Mars's diverse landscapes, from ancient river deltas in Jezero Crater to layered sedimentary rocks in Mount Sharp, reveal a history shaped by liquid water. Geological evidence points to periods of lakes, rivers, and possibly even a more stable climate billions of years ago. Detailed analysis of clay and carbonate deposits shows environments that may have supported life. Atmospheric studies, such as tracking methane variations and the effects of dust storms, offer insights into Mars' transformation from a warmer, wetter world to its current arid state. Together, these findings reshape our understanding of Mars' potential to host life and similar processes on other planets, one step at a time. Did Mars support life? For decades, scientists have sought answers to the tantalizing question, did Mars ever harbor life? While no direct evidence has been found, intriguing signs continue to emerge. One of the most debated discoveries involves fossil-like structures embedded in ancient Martian rocks. Past rovers have captured detailed images of peculiar formations resembling microbial colonies, hinting at life's potential existence in Mars' wetter past. Further strengthening this possibility is the detection of organic molecules, carbon-based compounds fundamental to life. Curiosity's SAM instrument revealed complex organic chemicals preserved in 3-billion-year-old mudstone, evidence that prebiotic chemistry once occurred. Perseverance has taken this investigation further, using its Sherlock instrument to hunt for biosignatures, microscopic features within rocks that might signify past microbial activity. The methods and tools employed are strikingly similar to techniques used to identify fossilized life forms on Earth. Water has always been central to the search for life on Mars. Ancient hydrated minerals and water-formed clays, found in abundance at Gale and Jezero craters, prove that liquid water was present for millions of years in the planet's early history. Gale craters' sedimentary layers suggest a long-standing lake system, while Jezero's delta formations indicate a similar, water-rich environment, both of which could have supported microbial life. In more recent history, Mars's water activity has diminished significantly, but not entirely. Subsurface radar mapping by orbiting satellites has detected vast quantities of water ice locked beneath the surface. Briny water, possibly flowing in underground pockets, offers a more intriguing prospect, one where microbial life, shielded from harmful radiation, might still exist. These findings continue to inform the rover's missions as they investigate areas where water may have left its mark. Perseverance has taken Mars exploration to a new level by focusing not just on studying rocks in situ, but by collecting and storing samples for eventual return to Earth. Using a meticulously designed drill, the rover has extracted core samples from carefully selected rocks in the Jezero crater region, focusing on areas that are most likely to retain evidence of ancient life. These core samples, sealed in titanium tubes, are Mars's first preserved specimens, awaiting transport in a future sample return mission. Bringing these samples to Earth is a monumental scientific and engineering challenge, requiring the combined efforts of NASA and the European Space Agency, ESA. A planned mission will involve multiple steps. A retrieval rover will collect the samples and load them into a rocket, which will launch the precious cargo into Mars's orbit. There, another spacecraft will capture the sample canister and bring it back to Earth, where advanced laboratories can conduct detailed analyses far beyond the capabilities of the rovers. This strategy is built on the collaborative efforts of international scientists who recognize that these rock cores might hold the ultimate prize, conclusive evidence of ancient microbial life on Mars. Whether or not life is found, the mission will provide groundbreaking insights into the conditions on Mars and their implications for habitability on other planets. The search for life is far from over, but every discovery brings us closer to answering one of humanity's oldest questions: are we alone in the universe? With Perseverance and its advanced capabilities, that answer might lie within the rocks and soil of a distant, dusty red planet. Technology and data transmission. The ability to visually document the Martian surface with incredible clarity is one of the most significant achievements of the Perseverance and Curiosity missions. Perseverance is equipped with the advanced Mastcam-Z, a pair of zoomable cameras capable of capturing high-resolution images and videos in true color and 3D. This system allows scientists to study intricate surface features, from the fine grains of sand to the layered sediments in Jezero crater, in unprecedented detail. By capturing 4K quality footage, Mastcam-Z bridges the gap between science and public interest, transforming distant Martian landscapes into visually accessible terrains for global audiences. Curiosity's ChemCam further revolutionized analysis by combining laser-induced breakdown spectroscopy with high-resolution imaging. It can vaporize rock surfaces from a distance of up to 7 meters and analyze their composition, providing key insights into Martian mineralogy without requiring physical samples. Together, these tools enable researchers to map the geochemical and physical properties of Mars, while significantly expanding our understanding of its geology and potential habitability. Innovations also extend to 3D mapping technology. Perseverance uses advanced imaging tools like RIMFAX to create detailed subsurface maps, revealing hidden geological features and potential pockets of water ice. This non-invasive approach enhances the scope of scientific discovery while preserving untouched Martian environments. Transmitting this wealth of data from Mars to Earth is no small feat. With an average distance of about 225 million kilometers, communication is constrained by bandwidth, transmission time, and equipment limitations. Rovers like Perseverance rely on relay support from orbiting satellites, including MAVEN and the Mars Reconnaissance Orbiter. These orbiters act as intermediaries, relaying high-volume data to Earth much faster than the rover could achieve on its own. However, transmitting high-resolution imagery and scientific data is bandwidth-intensive. On an ideal day, a rover may send around 500 megabytes of data, but the actual transfer depends on factors such as solar power availability and orbital alignment. Earth-based ground stations, such as NASA's Deep Space Network, are critical for receiving this data. Even so, there can be delays of up to 20 minutes in signal transmission due to the speed of light over such immense distances. Mars exploration continually pushes technological boundaries, and future missions aim to expand on current capabilities. New generations of AI-driven imaging systems promise enhanced real-time analysis, allowing rovers to make autonomous decisions about where to focus their tools. This could significantly reduce dependence on Earth-based instructions and enable more dynamic exploration. Sensors are also becoming more precise and versatile. Future instruments are expected to integrate advanced spectrometry techniques capable of detecting even trace amounts of biosignatures or chemical anomalies, enhancing the search for life. On the data transmission front, concepts like laser-based communication systems are being developed to replace traditional radio waves. These systems can potentially transmit gigabits of data per second, enabling quicker delivery of ultra-high-definition imagery and scientific findings. Ultimately, these advancements will not only refine the study of Mars, but also serve as blueprints for exploring more distant worlds, where even greater technological innovations will be needed. By continuously improving our tools and methods, Mars missions ensure that humanity's understanding of the Red Planet grows sharper and more detailed with each passing year from every angle possible. The Ingenuity helicopter, aerial exploration of Mars. The Ingenuity helicopter represents a groundbreaking leap in interplanetary technology. Designed as an experimental demonstration, this small autonomous rotorcraft was built to operate in Mars' extremely thin atmosphere, which has just 1% of Earth's density. Its success marks the first ever powered flight on another planet. Key engineering breakthroughs were necessary to make this possible. Ingenuity is compact, with a height of 0.49 meters and a mass of just 1.8 kilograms. Its twin counter-rotating blades span 1.2 meters and spin at roughly 2,400 RPM, much faster than typical helicopters on Earth. This speed compensates for Mars's sparse air, providing the lift needed to remain aloft. The helicopter is equipped with solar panels for charging, a high-resolution downward-facing camera, and autonomous navigation software, enabling it to fly without real-time input from Earth. Ingenuity's flight altitude ranges from 3 to 12 meters, with horizontal flights extending up to 700 meters. Its onboard technology, while minimalist, delivers critical data that paves the way for future aerial explorers. Ingenuity's first flight on April 19, 2021, lasted a mere 39.1 seconds, during which it ascended to 3 meters before safely landing. This historic moment demonstrated that controlled flight was viable on Mars, validating years of theoretical calculations and testing. What began as a technology demonstration quickly evolved into a vital reconnaissance tool. As of now, Ingenuity has completed over 50 successful flights, covering more than 12 kilometers in total. Its subsequent missions have included scouting ahead for Perseverance, mapping terrain, and identifying pathways too risky for the rover to navigate. This ability to survey Martian landscapes from the air has allowed scientists to efficiently target areas of interest, such as potential sampling sites in Jezero crater's delta region. The helicopter's aerial vantage point provides insights unattainable from the ground, enhancing understanding of Mars' surface and guiding Perseverance's route. Ingenuity's performance underscores the potential of aerial exploration to transform planetary science, offering both logistical advantages and new scientific opportunities. The success of Ingenuity has sparked interest in future missions involving more advanced aerial vehicles. Scientists envision fleets of rotorcraft exploring Mars independently, capable of traversing rugged terrain, scaling cliffs, or even probing the interiors of lava tubes. These capabilities would complement rover missions, creating a new era of integrated exploration. Beyond Mars, Ingenuity has set the stage for the development of similar technologies for other worlds. Notable future projects include the Dragonfly mission to Saturn's moon Titan, where aerial exploration will unlock entirely new opportunities to study extraterrestrial environments. Ingenuity's achievements demonstrate the transformative potential of aerial technology, proving that even in Mars's harsh conditions, engineering ingenuity can expand humanity's reach and its understanding across planetary frontiers. Perseverance and Curiosity, side-by-side achievements. Both Curiosity and Perseverance have redefined our understanding of Mars, each offering unique contributions to the science of planetary exploration. Curiosity landed in Gale Crater in 2012 with the mission to investigate whether Mars could have ever supported microbial life. It discovered ancient lake beds, provided concrete evidence of water-altered rocks, and detected methane fluctuations, hinting at possible biological or geological activity. Its ChemCam and SAM instruments identified organic molecules in Martian rocks, a critical step in the search for life. Perseverance, landing in the Jezero crater in 2021, extended this quest by focusing explicitly on finding biosignatures, evidence of ancient microbial life. The rover has collected multiple rock core samples, some of which show signs of water-altered minerals. Its unique tools, like Sherlock and Pixel, allow precise chemical and mineral mapping of Martian rocks, crucial for analyzing potential evidence of past life. Together, these rovers provide complementary datasets. Curiosity's findings laid the groundwork by confirming Mars' past habitability, while Perseverance refines this narrative, actively seeking signs of life and preparing key samples for return to Earth. Curiosity, now over a decade into its mission, has exceeded expectations in longevity and productivity. It successfully climbed Mount Sharp, uncovering geological layers that reflect Mars's changing climate. This achievement provided a timeline of environmental shifts from a wet to a dry planet. Recent missions continue to reveal evidence of clay-rich formations, expanding the narrative of Mars's watery past. Perseverance, in just 2 years of operation, has achieved remarkable milestones. It completed the first collection of rock cores destined for Earth return missions, tested groundbreaking technologies like the MOXIE for producing oxygen, and deployed Ingenuity, the first helicopter to fly on Mars. These successes are pivotal for advancing human exploration of the Red Planet. Both missions are products of decades of innovation and coordination, primarily led by NASA's Jet Propulsion Laboratory. International contributions, such as instruments from Spain, Norway, and France, have significantly enhanced the rover's capabilities. Collaborations like the European Space Agency's involvement in future sample return missions highlight the global effort to decode Mars's secrets. The longevity of these rovers is a testament to robust engineering. Curiosity, originally designed for a 2-year mission, has operated for over 11 years, enduring harsh Martian conditions. Perseverance benefits from this legacy, featuring more durable wheels and advanced systems for adaptability. Engineers at JPL continually update their operational software, optimizing each rover's performance for the evolving Martian terrain. In tandem, Perseverance and Curiosity represent humanity's most ambitious attempts to unravel Mars' mysteries. Their complementary missions build a compelling case for the planet's habitability, inching closer to answering the age-old question, are we alone in the universe? Public impact and the power of Mars exploration. The Mars rovers have not only revolutionized science, but also transformed public perception of space exploration. Through high-resolution images and videos, they bring an alien world to life, allowing humanity to experience Mars without leaving Earth. The 4K footage captured by Perseverance elevates this connection, showing the red planet's dramatic landscapes in unparalleled detail. From sweeping views of the Jezero crater delta to close-ups of rocks with potential biosignatures, this visual clarity fosters a deeper understanding of Mars' environment. Interactive platforms like NASA's Mars Trek and public-facing missions, such as naming features on Mars, actively engage millions of people worldwide. These tools break down the barriers between advanced science and society, making the Mars mission feel like a shared global endeavor. The impact of Mars exploration reaches classrooms across the globe, inspiring an interest in STEM. Programs like NASA's Perseverance Student Challenge have directly involved students in problem-solving exercises modeled after real mission scenarios. Teachers use images and data collected by the rovers to explain complex concepts like geology, chemistry, and physics, igniting curiosity in young minds. The missions also inspire the next generation of scientists and engineers. Seeing technological marvels like Ingenuity's historic flights or the MOXIE oxygen production experiment in action gives students a glimpse of what's possible through innovation and persistence. This not only bolsters scientific curiosity, but also fosters an appreciation for teamwork and long-term planning essential in planetary exploration. The public's fascination with Mars is reflected in its integration into global culture. Countless books, films, and artworks have drawn inspiration from the Red Planet, fueled further by the rover's vivid depictions of its surface. Perseverance's 4K videos have influenced visual storytelling, inspiring realistic portrayals of Martian landscapes in movies and virtual reality experiences. For artists, the stark terrain, red sands, rugged cliffs, and alien skies offers a blank canvas to explore themes of isolation, resilience, and discovery. Writers craft narratives around what these rovers symbolize: humanity's relentless pursuit of answers. From NASA documentaries to Hollywood blockbusters like The Martian, Mars has audiences while bridging the gap between imagination and reality, paving the way for human exploration. Curiosity and perseverance are laying the groundwork for human missions to Mars, providing critical insights about the planet's terrain, resources, and hazards. By analyzing rocks, soil, and the atmosphere, these rovers help identify potential landing sites and regions with vital resources like water ice. This data is key for sustaining human life on Mars, enabling the creation of drinking water, breathable oxygen, and even fuel for return trips. Perseverance's MOXIE is particularly groundbreaking. By extracting oxygen from Martian carbon dioxide, MOXIE demonstrates how future habitats could produce life support essentials locally, rather than relying on costly resupply missions from Earth. Terrain mapping and imaging, made possible through tools like Perseverance's MastCam-Z, aid planners in designing rovers, habitats, and equipment suited to the planet's unique challenges. The success of robotic missions has fueled ambitious plans for manned missions to Mars. NASA's Artemis program, focused on returning humans to the Moon by the late 2020s, is seen as a stepping stone for deep space exploration. By 2033, NASA aims to send astronauts to orbit Mars, potentially leading to surface missions later. SpaceX, driven by Elon Musk's vision of a multi-planetary species, is aggressively developing its Starship spacecraft, designed for mass transportation of humans and cargo to Mars. SpaceX's timeline is bold, targeting a potential Mars landing by the early 2030s. The collaboration between government agencies like NASA and private companies such as SpaceX could fast-track progress, combining NASA's expertise with SpaceX's rapid innovation. Exploration of Mars is shaping strategies for sustainable living in extreme environments. Challenges like building radiation-shielded habitats, extracting water from soil, and generating energy from renewable sources offer invaluable insights not only for Mars, but also for exploring other celestial bodies like Europa or Titan. Mars acts as a testbed for developing closed-loop systems essential for survival far from Earth. Technologies refined on the red planet, such as recycling oxygen and water or autonomously repairing infrastructure, are stepping stones for exploring the outer solar system. The knowledge gained from Martian exploration offers hope for overcoming the limits of Earth's resources. With every rover mission, humanity edges closer to creating a second home, transforming the dream of interplanetary living into an achievable reality. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.